What's up, guys? Welcome back to a brand new academic learning video, and in this video we are going to be covering nested radicals. Wow. Okay, so first of all, what is a nested radical? Or just what's a radical? So, a radical, so you may be familiar with like square roots, right? The square root of something. To find the square root of a number, you just question what number times what number equals that number. So what number squared gives us the number inside, or 9. And this is just 3 in this case, because 3 squared is 9. But it's not just square roots as well. There can also be cube roots, and fourth roots, and fifth roots, or in general, nth roots. And this is basically the same thing. If we have like the cube root of 8, that's what number, when we cube it, we get 8. And in that case, it's 2. If you have the fourth root of 16, what number, when we take it to the fourth power, we get 16th. And that's just 2. So you can see how this idea can kind of generalize. And in general, we like to call these things where we have like what number to the blank power equals the number on inside. Those are called radicals, just in general. Radicals. But most often, you'll hear the term radicals just applied to square roots, because square roots are by far the most useful of all of them. Okay, so now that we've gone over radicals, what are nested radicals? Well, there's square roots of numbers, right? You're probably familiar with that. But there's also square roots of expressions. So let's say we have the square root of x squared plus 2x plus 1. Okay, now this may seem impossible to solve. Like, what number squared equals x squared plus 2x plus 1? But what if I rewrote this? Now, if you don't know how to factor quadratics, then you can watch my factoring videos, link in the description. But let's just factor this right here. So you may recognize this is a perfect square trinomial, but let's say you didn't know that. Then what would this be? Well, that would be two numbers that add to 1. No, two numbers that multiply to 1 and add to 2. So that's just going to be 1 and 1, right? Oh, but hey, look, they're the same thing. So that's just x plus 1 all squared. Because if that's just a number times a number, that's just the number squared. And this is basically, if you don't know what a perfect square trinomial is, this is basically what it is. It's just a number that we can rewrite as a square. Now, how do we recognize if something's a perfect square trinomial? Well, we can just picture, if we have something like a plus, or actually not a plus b, let's do x plus y squared. Well, then this is just x plus y. And again, if you haven't seen my factoring video, this is how we do factors in general. We just take a product and then we expand it, and then we see how to work backwards. And you'll see what I mean in a minute here. So just using double distribution, this would be x squared plus xy, or some people like to call it the FOIL method. And again, I also cover how to expand quadratics in my other method here, in my factoring video, so you can check that out. Okay, so we can see here that if we just have, we know that if we can write the expression as x plus y squared, where x and y, where they can be variables, numbers, pretty much whatever we want. In this case, x is a variable and y is a number. Then we can rewrite that as x squared plus 2xy plus y squared. So let's see if we can do that here. So for x squared plus 2x plus 1, that means we can rewrite that. If this can be rewritten as x plus y all squared, then we can rewrite this expanded term into this expression right here. So x squared, that's just pretty obvious. We have x squared, 2xy. Well, we already have the 2 in the x, so that means y must be 1. This also follows because y squared is also 1, so 1 squared. And that matches up with that constant. So now we can see if we can rewrite it in this form, then we know this is just a perfect square trinomial. And how to find it? Well, if it's x squared, then this becomes x. And if it's y squared, then this becomes y. So 1 squared, that becomes 1. So you can kind of picture it as taking the square root, because that and that cancel and you just get x, but this is how I like to think of it. Okay, so now that we've covered perfect squared trinomials, let's see how we can finish this problem. Sorry about that. Okay, so we've reduced this expression to x plus y all squared. Now, how can we further reduce this? Well, remember, the definition of a square root is just what number, when we square it, will give the thing inside. Well, what number, when we square it, will give x plus 1 squared? That's just x plus 1, right? And some people like to interpret this as the square root and the square canceling out, but that leads to some math extraneous solutions, but we're not going to cover that in other videos. Okay, so now we've seen we can turn a complicated algebraic expression, the square root, and by just transforming it into perfect square trinomials, we can get just a nice expression without a square root. But please make sure this only works with perfect square trinomials. So make sure you can check it's a perfect square trinomial. And here's a quick way to check. X plus 9 square root plus 6x. So here's a quick way to check. So we have x squared plus 2xy plus y squared, right? So we can just check x squared, so then y must be 9, right? And then check if y is 9, is this 2 times x plus y? So this is 2 times x, y must be 3, right? Because 3 squared is 9. So is this 2 times x times 3? In this case, it is. So that's a quick way to check. But not all polynomials are like that. If you have something like just x squared plus 2x plus 2, we see that for this to be x squared plus 2xy plus y squared, well then the x squareds match up because they're just x squared. But y squared to be 2, that means y is the square root of 2, right? And then, so now we just check 2xy. If you have 2 times x times the square root of 2, is that equal to 2x? In this case, it's not. So just be on the lookout if that is a true condition. Okay, now let's move on to actual nested radicals. So that's just plain old radicals. Now let's cover nested radicals. Now nested radicals are like radicals, except there's one thing different about them. You have one radical like this, but now you have 2 radicals. What? So you have a radical inside a radical. That's why it's called a nested radical. So let's cover a basic example of nested radicals. Let's say we have the square root of the square root, let's just say a number, the square root of the square root of 16. Well, this is going to be, what's the square root of, we work from the inside first and then go to the outside. So what's the square root of 16? 4, square root of 4, 2. So that's a pretty basic example. But now let's replace it with some algebraic expressions. Ooh. So instead of 16, how about we do, sorry about that. How about we do the square root of the square root of x plus 3 to the 4th power. Okay, so work inside. What number, when we square it, gives x plus 3 to the 4th power? This is just x plus 3 squared, because we have x plus 3 times x plus 3 squared times x plus 3 squared. So we're squaring it by multiplying it by itself twice. We can kind of think of it as adding the exponents, right? See my exponent property video if you don't know that. And you get x plus 3 to the 4th power. So what number, when we square it, would give us x plus 3 to the 4th power? That's just going to be x plus 3 squared, right? X plus 3 squared. Oh, and now we have this nice other expression. What number squared gives us x plus 3? That's just x plus 3. And again, you can kind of think that as canceling it out. Or another way you can think of this is you can translate these radicals into half powers. And if you don't know that radicals can be written as half powers, again, I have another video on that. Feels like I have a video on everything. Okay, so then now we can just use exponent rules. X plus, this is a bit confusing, but don't worry, you can just take it step by step. X plus 4 to the 4th power to the 1/2 power. Now exponent rules, we just multiply these two exponents. So 4 times 1/2, that's just squared. And now we have one more thing. You raise all of this to the 1/2 power, and again, multiply it again. So that's just going to be x to the 4th to the 1, because 2 times 1/2 is 1. Or, sorry, did I write 4 here for some reason? Oh, these should all be 3s. Yeah, I don't know why I changed that to a 4. Okay, so now you can see how nested radicals, we can just take them step by step. We can break them up into smaller radicals. And you might notice that how square roots, we like to have something squared, and then we can cancel them out. With nested radicals, we have something to the 4th power, and then we can cancel them out. Okay, so let's move on to some harder examples now. So a nested radical may not just be plain old radical, then you have something inside here. They can be something like, what if we have a radical times like 3 times the square root of something? Or what if we have a radical, and here we have something like 2 times the square root of 2 plus 3. We have a radical inside of a radical, but we also have some other stuff. So how do we do this problem? So first you may think it's pretty impossible because, well, if this was multiplied, then we can just use radical rules, right? If this was just multiplied by 3, then this would be 6 root 2. And then from radical rules, we can just convert to exponents, right? 2 to the 1/2. Then raise that to the 1/2 power. And now we just multiply Now we just multiply here to get 6 to the 1/2 times 2 to the 1/4. And again, if you don't know that, I have a radical properties video. But here, it's not multiplied, it's added. So how would we do this? Well, one way, this requires a bit of clever thinking, but one way you can think of this, well, what is 3? 3 is 2 plus 1, right? That's pretty obvious. So, instead of 3, we can just write 2 plus 1. And now, do you notice anything about this? Well, don't feel bad if you don't know, because you only really start to notice these things once you've done a lot of problems like this. But how about if we write it like this? Now, let's see. So, for perfect square trinomials, I said that could be an exponent, they could be real numbers, but in this case, they could be a variable, it could be real numbers. So, these are real numbers. So let's see if we can use perfect square trinomials. X squared plus y squared plus 2xy. Let's see if these line up. Okay, so x squared is 2, and y squared is 1. So, let's see. So if x squared is 2, then that means x is the square root of 2. And if y squared is 1, then that means y is the square root of 1, which is just 1. Okay, so now we know that so now to know if it's truly a perfect square trinomial, we just have to check. If 2xy is 2 times square root of 2. So 2 times x, which is square root of 2, times y, which is 1, that's equal to 2 square root of 2. So it is a perfect square trinomial. Let me shrink this down a little bit here. Okay, so now we know this is a perfect square trinomial. So we can write this as x plus y all squared. In this case, x is square root of 2, so we can write this as square root of 2, and y is 1. So we can rewrite this as square root of 2 plus 1 all squared. Aha! And now we can just do this little trick. Again, this isn't really is happening, but I mean, I guess you could kind of think of it like that if we convert this to 1/2, but I don't really want to get into it. So this is just square root of 2 plus 1. So that's a clever trick we can do here. So here, if we just lined it up as, well, for a perfect square trinomial, it's called trinomial for a reason. There needs to be 3 terms, 1x, 1y, and 1x squared, 1y squared, and 2xy. So we can convert this into 3 terms by just splitting this 3. Oh, sorry about that. Okay, sorry about that. So we can just convert this 3 into a 2 plus 1. So that splits it up into 3 terms. Now we can check if 1 is an x squared, 1 is a y squared, and then we can, we assign x squared and y squared to 2 of the terms, and then check if the term in the middle is 2 times xy. Now, you may have a couple of questions about perfect square trinomials, like, why do we assign this to x squared? Why don't we assign 2 root 2 to x squared? Well, the truth is, it's kind of just guess and check, but as you get used to it, usually, because 2 is x squared, then if we take the square root, that's going to be, if we take the square root, then that's usually going to be associated with x. But if we have x squared, let's say this might be a bit confusing. So let's say x is the square root of a number, but x squared won't be, because the square roots and the squares will cancel. So that's why, for the x's and y's, because they're squares, they're usually going to be the constants, in this scenario at least. So that's why the one with the radicals are usually going to be the middle term, because x will be a square root sometimes. But if there's a square root, then it's probably going to be the middle term. Hopefully that makes sense. But if not, again, you can always just leave a comment. Okay, so this is a pretty cool trick. We can just split it up into 2, and then, yeah, I encourage you to find some more problems like this and try to see if you can solve them, because they are some very cool problems. Alright, so that's going to be about it for this academic learning video. I know this was a bit different. Like, usually I covered some school topics, but this topic isn't really covered in school, so hopefully you liked it. Hopefully that last trick at the end was cool, and I hope you enjoyed. And if you have any questions, as always, just leave it in the comments below. And yeah, I'll see you next time.